Hello everyone, this is Chapter 7, number 91, Standard Collisions. So the question asks us, what is the speed of the target body after the collision if the collision is perfectly elastic? The perfectly elastic part is important, will come in later. But for now, so it tells us the projectile is initially moving in the x direction, so we could say the initial velocity of the projectile. It gives us 8 meters per second. We're going to use that as a VIP equals 8 meters per second of the x component. And then it says after it hits the target, it is deflected at a 90-degree angle in the positive y direction. So therefore, we can say the final velocity projectile of the y component, which should be a y right here, is 6 meters per second. It gives us the mass of the projectile, and we're going to go ahead and say the mass of the target is equal to m. For simplicity's sake, it may seem confusing at first, but it'll make sense later. So we know that momentum is conserved, so we can go ahead and write this equation out. The mass of the projectile, initial velocity of the projectile equals the mass of the target, the velocity of the target, and the x component. So this will be the x component, and we're going to solve for the target's velocity in the x component. So yeah, we write out everything right here, and we'll get this right here, which this m, it doesn't make sense right now, but this m we're going to use later. But if we did have a mass here, these would cancel out and it'd be 16 meters per second. So our units are correct right here. We're going to do the same thing for the y right here, and then we're going to go ahead and solve for the velocity, the target velocity vector, and we'll end up with 20 kilograms meters per second over m, which, like I said, we're going to use that m for later. So since it says that the collision is perfectly elastic, we could say there's no kinetic energy lost during the collision. So we could go ahead and write this equation out right here, and where Ke equals 1/2 mv squared, and this is going to be the kinetic energy of the target right here. So we're going to plug in everything in this mess right here. These are all given values, and we just solve for this velocity right here, and this is where the m plays in, and we're going to get m alone, so we solve them for m. We'll end up with 7.14 kilograms for the mass of the target. That would be the mass of the target. And for the final part, we're just going to use this momentum equation right here to solve for the velocity of the target. I mean, it may seem weird because we did solve for the velocity up there, but we didn't have the m. We used it in that equation up there to find m, so now we can use m to solve for the actual velocity of the target, which would be 2.8 meters per second. And that would be the answer to our question right here, the speed of the target after the collision. Thank you. Hope you all learned something.